Hello, I'm Ron Bilyeu. I'd like to welcome you to my shop. Today we're going to be discussing a bit of a dilemma in our industry. To give you an idea of what I'm talking about, it kind of sums up a lot of it when we look at these two patches. Do you want to be this technician or do you strive to be this technician? We're going to be doing a lot of discussion about this. I mean, we're always looking for the silver bullet, the programmed response to problems. But that's really not the answer. A professional level technician will have a series of steps that he will go through and how he will approach the problem. It's going to generate revenue in the shop, it's going to make you more of a professional technician, and you're going to end up with happier customers. We do have a Camaro here that is a case study that's related to what we're going to be talking about. I've got some case studies from the past we're going to be going over, and then we're going to spend some time on this Camaro. It is a 2011 Camaro with a 3.6 with the venerable cam timing problems. Kind of ironic, the customer said that they did some research on the internet and they approached my shop and me and said, how much would you charge to replace all 4 of my camshaft sensors? Can you believe my vehicle has 4 camshaft sensors? I said, yes, I believe your vehicle has 4 camshaft sensors. What I don't believe is they all went bad at the same time. So we're going to investigate what's going on here, along with some other case studies. One thing we don't want to do is we look here, go right to the internet for the cure. Yeah, it helps. Your main function is to find the problem with the vehicle. But trust me, there is an approach, there are steps that a professional level technician will take. Let's go over some reasons why we want to make sure that we have a diagnostic process and steps that we want to go over. On the internet, there's lots of writers and no editors. You don't know where that information is coming from. There's a lack of clear and concise information. You really should be using a professional automotive information system. Non-professional wannabe technicians. You might be getting information that somebody that's not even a professional level technician, that's kind of a do-it-yourselfer in the backyard. That's not the professional way to do it. They usually, as you search the internet, you won't find a defined answer. You will find multiple solutions. How do you pick when you have multiple solutions or multiple pieces of information on to fix the vehicle? I'd rather you use your own personal experience, customer information, your research, your scan tool, your diagnostics, and arrive at the problem than to be looking on the internet for a cure-all, fix-all. Let's talk about the correct professional method. It should start off with customer information. Yes, that can be difficult. Many customers do not want to just open up to you and tell you all of the problems with the vehicle. They figure that the more information that they give you, if it's this long drawn-out report on problems with the vehicle, that they're going to have an exuberant bill. That's really not the case here. The more information that the customer can give us about when, where, how, what's going on with the problem vehicle, the more information we have, the quicker we're going to diagnose the problem and get to the root cause. We need to know how long the vehicle has had the problem, the condition when the vehicle problem occurs, the road conditions, what are the weather, how long has the engine been running, has there been previous repairs done, and is there documentation of these repairs? And you need to follow up and make sure that those repairs were done correctly. There'll be telltale signs of gaskets replacement, parts replacement. You can tell if there's been an area on the vehicle that's been disturbed, or you can tell if there's new parts versus old parts. You need to see what attempts have been made to repair the vehicle. And how does the customer drive the vehicle? Are they on the interstate for a prolonged time? Is it all city driving? All of this information is beneficial in helping you decide what is the correct path of diagnostics and what your next move is based upon the customer information. Plus, when you go on the test drive, you'll be able to duplicate the conditions, hopefully, that the customer described the problem is occurring at. Customer information is very important, and I know as an automotive technician, you may not be the person that meets and greets the customer. You may be getting this information secondhand from a service writer or a service advisor. If this isn't the case, then the shop that you work at should be utilizing customer interview reports so that that information, the customer can fill out that information, not unlike going to the doctor when they want to know your family medical history and your medical history. We want to know the history of the vehicle written down, especially when we don't get to meet and greet the customer. The next thing we want to discuss in the diagnostic process is a good inspection. You want to look at that vehicle really like you were planning on buying it for yourself or your mother or father or relative, your wife, husband. You really want to give that vehicle a good inspection. Some points that we want to make sure we cover in an inspection: fluid levels and what did the fluid look like. We all know what brake fluid should look like, transmission fluid should look like, oil should look like. We want to really do a good fluid inspection, color, dirtiness, all of that. Is there a lot of varnish or tarnish? If you inspect the oil filler cap or the dipstick tube, look for worn components, belts being worn, hoses being worn, worn components on the engine, abnormal engine noise. Look for new parts that have been replaced and the documentation that goes along with that there may have been a previous attempt to repair the vehicle. We want to inspect the routing of wiring. We want to look for missing components. We want to make sure that we don't have any major leaks on the vehicle. All of this is part of a really good inspection. A lot of times you'll find the problem by just using your senses. Sight, smell are very powerful in helping to diagnose the vehicle. Another step that we absolutely cannot miss is research. Research that there may be some upgraded parts, some technical service bulletins, and you would be amazed when you do the research of how many vehicles that have a particular module on the vehicle that has an update. There are many shops across the country that do not have the J2534 programming tool to be getting into the business of reflashing modules. All I can say to you is you are losing a ton of revenue. In the future, when we're looking at autonomous vehicles, 90% of the repairs are going to be reflashing the modules on the vehicle. General Motors says that vehicles out of warranty, there's over 60% of the vehicles on the road that may have a module that needs to be updated. You could be a hero, meaning if you make that vehicle run better, get better fuel economy, improve drivability, improve performance, better than it ever did, you're a hero and you'll have a customer for life. I know a lot of shops in the beginning got into the module reflashing and they ran into some pitfalls. If the cable came loose, if the battery wasn't fully charged, many shops were purchasing an expensive computer or module. Really, today we don't have that problem. The manufacturers of the tools, the software have recovery modes. Just the other day, a former student of mine was telling me about how the fact that somebody was playing around in the shop and unplugged the cable while he was reflashing a new 6.7 Ford diesel. He looked at the guy and goes, "They're going to take that out of your paycheck. That was an expensive, stupid move." Well, lo and behold, he went back in and the IDS, the Ford factory tool, recovered and was able to reprogram it without replacing an expensive PCM. Myself, one time I was reflashing a Corvette and the customer next to me, or not the customer, my neighbor, was mowing his yard. He stopped the lawnmower, came over and opened up the door, stuck his head and goes, "This is a really cool car." When he did that, he excited the right door module and corrupted the programming and cost me $287.50 for a PCM. Those days don't exist anymore. We have warnings that if the battery's not charged, we have recovery modes, And you really should, if you're not doing it, you need to be in the module reflashing business. You'd hate to spend 2 to 3 hours trying to figure out a problem only to find out there's a better improved part or a reflash or a module or a technical service bulletin to add a particular part. You have to take the time to do the research. And many times the research will include, as far as drivability and electrical problems, it'll include studying the map. What I call the map is the wiring diagram. The wiring diagram is a wealth of information to show you how things work, where power, ground, where they go, what things they feed. We actually have a case study that knowing and doing the research for the wiring diagram is an important key process that fixes a case study we have coming up on a Dodge truck. This information is available to us from the OE manufacturers. You don't have to scour the internet trying to find a quick and easy fix. The information is available, professional level information, correct wiring diagrams, technical service bulletins, preliminary information bulletins, publications. You definitely want to utilize those. The manufacturers really can't withhold this information from us. They can charge us for it, but really that's all part of being a professional. We're going to start utilizing some equipment in our diagnostic process. I'm sure everyone will want to know or try to retrieve trouble codes, but are you really doing it the correct way? You see, modules like to tell on each other. The other day I was discussing a diagnostic fee to my customer, and when I got to the point of discussing diagnostic trouble codes, they said, well, my local parts store will check my codes for free. Really? Have you ever noticed what they're checking? They use a generic or global scan tool and access the global side of the PCM. What if there's P1 manufacturer discretionary codes? You don't see it. What if the car has 12 other modules that are all on the same network and one of them doesn't like what one of the other ones are doing and it sets a trouble code? They'll have no idea. Here's the difference. A professional technician will use a professional level scan tool, and he'll do what Toyota has called it for many years, a health check, or I like to call it an all system scan, which you're going to scan all the trouble codes on every module. That's the professional way of doing it. You know, a lot of times I make reference to doctors. And, you know, a doctor may look at you because you have back pain and he'll say, well, I'll send you out for an x-ray. Maybe the x-ray will tell us why you have pain in your back. But in reality, he would love to send you out for an MRI because it gives him a lot more information about what's going on and can probably pinpoint where the pain is in your back. I like to tell my customers, when you go to the local parts store and they come out with a generic scan tool, you're getting an x-ray. When you come to me, a professional technician, the way that we all should be doing it, you're getting an MRI. You're getting an all system scan. And that's why we charge for a diagnostic fee. Not to be misunderstood, there is value to the global side of the scan tool. You just can't attack the vehicle problem as far as the scan tool goes with just the global or generic side. I do want you as a professional level technician to utilize the global scan tool. In some cases, for example, you know, if we're working on a GM product, we have excellent history and current misfire information, but not all imports, Asian, European, and not all domestic vehicles give us this information. So a lot of times we may have to go into mode 6 to find the misfire counters for the individual cylinders. I have a really good tip. As we start moving ahead in the future, there's going to be more and more autonomous vehicles. Since 2008, we've had level 2 autonomous vehicles. But how do you know that the vehicle you're working on has this type of information or has these types of services for the customer? Lane assist, parking assist, adaptive cruise control. Well, here's the tip. That global scan tool now has mode 9 information. When you enter mode 9, it's going to populate or ping every module that's on that vehicle and describe those to you. Therefore, you can go down the list and see if it has these safety features and the modules that go along with them to determine that it is an autonomous level 2 vehicle, or even today now we have a few level 3 vehicles. So there's definitely a place that can help us diagnose the vehicle and access information that is helpful in getting to the root cause by utilizing the global side of the scan tool. Maybe there's faults that haven't matured to a pending code or an actual code. What I call these are the notes of the task manager or the executive director of OBD2. If you want to see his notes, you got to go into the global side of the scan tool and look at the different modes. Many professional level scan tools will flag any problems, things that are outside of the norm but haven't yet set a trouble code. These can be high-level indicators to help you diagnose the car right the first time. Another reason that you may utilize the global side of the scan tool, in some applications, this may be the only area that you will find freeze frame data. The bad point of that is that you're only going to have freeze frame data for global trouble codes that are P0 codes. In my travels across the country training technicians, I've run into a mistake that I see technicians do quite a little bit. The problem is they'll get the trouble code, they'll clear it, and when they're on their test drive, they want to see if the trouble code comes back. Well, before you clear that trouble code, you may want to take a long, hard look at freeze frame data. That way you'll know that that's not when the light came on, that's when the fault occurred. So you will have very, very important information on where to test drive this vehicle. What engine temperature, what load, what mode of operation, vehicle speed, all of this information so that you can duplicate the conditions as close as possible to surface that problem and help you diagnose the car quickly. So before you go on that test drive, before you start that engine, I've got a couple tips for you. If you have the luxury that the vehicle has been setting for several hours or overnight, then there's a few data PIDs that you want to look at very closely. First of all, let's say the vehicle you're working on has intake air temp sensor, cylinder head temp sensor, coolant temp sensor. I mean, General Motors has new mass airflow sensors now that are called mini weather stations. The mass airflow sensor itself has 2 intake air temp sensors. Here's the tip. With the key on, engine off, the vehicle's been setting for at least 3 to 4 hours. Shouldn't all the temp sensors read the same? Coolant temp, cylinder head temp, intake air temp, high speed, low speed, they should all read the same. Here's another tip. Also at that same time, you may have a barometric pressure sensor in the computer. You may be a turbocharged vehicle like a Ford EcoBoost and have several pressure temperature sensors. The pressure in the charge air cooler, the pressure in front of the throttle body, the pressure in the intake manifold, the pressure in the wastegate actuators for the turbos, there might be 2 of them. There might be as many as 5 to 6 different pressure sensors. They all should read the same pressure, key on, engine off. The engine's not running. The atmospheric pressure at the charge air cooler, in front of the throttle body, in the intake manifold, they should all match. If one sensor's out of range, it's going to stick out like a sore thumb, and it's going to help you in your diagnosis really fast. Now you're starting the engine. The engine's starting to warm up. 3 things have to happen to achieve closed loop mode. One is a timer inside the computer must elapse. How much time? Well, it depends on what is the startup coolant temperature. If the startup coolant temperature is the first thing in the morning, the timer may be set for 2 to 3 minutes. If you just went into a convenience store, grabbed a loaf of bread and a gallon of milk and came back out, the timer's probably 1 to 2 seconds. But the timer is based upon startup coolant temperature. The next thing is there will be an enable closed loop engine temperature. Most of the time we can go closed loop in as little as 100 degrees Fahrenheit. So the timer has elapsed. The engine is over 100 degrees for closed loop enable. Now we're looking at the oxygen sensor. The oxygen sensor has to be hot enough to go to work. If it's a narrowband oxygen sensor, it needs to be around 600 to 700 degrees. If it is a wideband air-fuel ratio sensor, it probably has to be somewhere between 11 and 1200 degrees. They have electric heaters to help us get into closed loop faster and to keep the oxygen sensor and air-fuel ratio sensors clean during cold engine operation when carbon buildup can be heavy. So we want to watch that all of these sensors and PIDs are getting us to closed loop information. Now we're in closed loop. We've achieved closed loop. We want to probably track our applied pedal position versus our throttle position. Remember, most vehicles nowadays are drive-by-wire. There's no mechanical cable. The best tips I can give you, the number one PIDs to look for once you've achieved closed loop is fuel trim. Short-term fuel trim, long-term fuel trim, and rear fuel trim added together gives you total fuel trim. Let me give you an example. Let's say, and I'm not even going to tell you the year, make, or model of the vehicle. I'm just going to say that total fuel trim is 25% at idle. Off idle, it's 8%. What's my problem? Well, think about what I'm saying. The computer wants to add so much more fuel at idle, but gets happy off idle. That's a dead giveaway to an air leak, a vacuum leak. Anytime I see that fuel trims improve, as soon as I come off of idle, I'm breaking out the smoke machine and I'm going to start searching for a vacuum leak first. Now, let's say that my fuel trims, as I'm cresting a hill or I'm increasing load, they rapidly start moving positive. That would tell me that I have a fuel delivery problem. It'll make me want to come back and check fuel pressure, fuel volume, and maybe I have good pressure and volume, but I have poor injector flow. But you know by how the computer is reacting, if it's adding or subtracting fuel, this is a wealth of information to help pinpoint the problem. On V engines, I've got some special tips. Let's say you hook up your scan tool, and as soon as you look at the data PID, one bank is positive all the way as far as it'll go. It's positive 35%. The other bank is negative 35%. At idle, part throttle, cruise, and every engine load and mode of operation, one bank is positive, one bank is all the way to the extreme negative. You wouldn't think this could happen a lot, but I'm telling you it does on Chargers, Challengers, Camaros, Corvette, Mustangs. The upstream oxygen sensors are crossed. It usually happens after it's been to a transmission shop or a shop has had the tranny out, put it in a clutch, an automatic transmission, or did some exhaust work. They will plug and play left to right and right to left. The dead giveaway are fuel trims are maxed out on opposite banks. Now, let's say fuel trims are within spec. They're between negative 10 and positive 10 at idle, but as we increase load, one side, one bank, say bank 1, takes off positive and bank 2 goes negative. It's a dead giveaway. I don't need to know the year, make, and model. You have a breathing problem on the negative bank. It could be a worn camshaft, a broken valve spring, cam timing is off, a hole in a piston. You have a mechanical breathing problem. And a mechanical breathing problem would also include a clogged catalytic converter just on that bank. So once you get used to these quick and precise tips and you can glance at what fuel trims are doing at different engine loads and modes of operation, this is great and a wealth of information to help pinpoint and diagnose the vehicle. So let's take a look at this Camaro, 2011 Camaro with a 3.6 engine. The customer brought it into the shop wanting a price on replacing all 4 camshaft sensors. Very unlikely that all 4 camshaft sensors failed at the same time. Also said that on startup, there was a loud ticking noise for just a brief moment in time, no more than a few seconds. There was a ticking noise coming from underneath the hood. We have a check engine light, service engine soon light, and the ticking noise we were able to duplicate as long as the engine was cold on startup. So let's take a look at some trouble codes that were set. Trouble codes was P008, engine position system performance, bank number 1, P009, engine position performance, bank 2, a P016, which is camshaft, crankshaft not plausible, and P017, crank camshaft not plausible on the exhaust. So we got intake and exhaust camshafts not plausible, meaning the computer does not like the relationship between the crankshaft sensor position and the camshaft sensor position. With the noise that we have, it's a dead ring indicator that we've got some slack in the timing chain until oil pressure comes up. Now I have a really good tip for you. Not that it works every time, but I'm at about 80% success rate. Here's what we're going to do. We are going to drain the oil. If this engine takes 6 quarts of oil, we're going to replace that oil with 6 quarts of inexpensive, don't buy any synthetic, any high dollar, automatic transmission fluid. Automatic transmission fluid is very high in detergent, and it's going to clean all of the components in the engine. You do not want to drive the vehicle. It only idles in the shop for 45 to 60 minutes just at idle. After 45 to 60 minutes, we're going to drain the automatic transmission fluid, fill the engine with the right viscosity, quality synthetic oil, and a new replacement filter. Many times by running the transmission fluid in the engine, it will clean up the varnish and the tarnish and get the oil flow improved, thus bringing the pressure up to the timing chain tensioners quickly and not having any cam to crank variation. One of the main reasons that we suspected that this was the problem with the noise is when we did an inspection of the oil filler cap, you can see some varnish and tarnish that's developing in the oil filler cap, which makes us think, down below, what does it look like? It's probably pretty nasty. Now, really what we need to do after all this is have a long conversation with the customer about the maintenance requirements of a modern multi-camshaft engine that they drive in this 2011 Camaro 3.6. However, if we would have followed proper procedure and the customer was really up on their maintenance, I explained to them that in my research, because I'm a professional technician, I did my research, I would have found that there is a bulletin that General Motors is extending the timing chain guide and timing chain and gears replacement for up to 120,000 miles, so long as the customer can provide receipts from every oil change and prove that the oil was changed in a timely manner. If they can prove that, General Motors would take care of the cost under warranty for replacement of the timing chain gears and guides. The customer said there's no way that they had that information to proceed and see if we could get them back on the road. So I have a tip for you in regards to problems with variable cam timing as this Camaro had. Obviously, one of the biggest things you have to look for is varnish, tarnish, oil sludge. We've never so much in the history of the automobile asked the oil to do so much. With active fuel management, displacement on demand, variable cam timing, where we're using the hydraulic leverage of oil to shift the camshaft position. Your best PIDs to look at are this. You may have what's called camshaft, crankshaft variation degrees. That is the offset that the computer's saying, hey, the cam and crank are not in the right relationship by this amount of degrees. Sometimes it's called crank camshaft sensor error. Some manufacturers call that. Some call it cam crank difference. And here, General Motors calls it cam crank variance. If you have any of those data PIDs, that's where you want to watch. As the cam and crank timing get farther apart, the number will grow higher. If you do not have the luxury of cam crank difference, cam crank variance, or cam crank error, you want to look at the desired versus the actual camshaft position. I like to overlay those so that if I watch the cam and crank, what the computer wants the camshaft to be and where it's at will also show you error. So you can utilize cam and crank desired versus actual if for some reason you do not have the error PIDs or the variation PIDs. The next case study I'd like to go over with you was a '04 Dodge Ram pickup that I had in the shop a few months back. It was a 4.7 liter engine, and I'm kind of going to show you some of the pitfalls of relying on the internet for the answer to fix the vehicle. The customer complaint is it bucks and jerks, lack of power with a check engine light. The customer did have trouble codes checked, went to the internet for the answer. The internet said to replace the crankshaft sensor. The crankshaft sensor was replaced. It did not fix the vehicle. So they removed the crankshaft sensor at another shop, and then they replaced the camshaft sensor, and that didn't fix the vehicle. Then it came to me with the information provided by the customer that they've already tried a crankshaft and a camshaft sensor. So we want to take the time to do some research. And the research included finding a known good crank and camshaft sensor relationship pattern and also studying the wiring diagrams. I can tell you that the answer is in the wiring diagrams and studying the crank and camshaft sensor and then putting the crank and camshaft sensor up on the scope. As it says, the internet said to replace the crankshaft sensor and it didn't fix the problem. So the problem pattern, as you can see, was kind of tough to see unless you were live on the vehicle, but the cam and crank were shifting back and forth. When you study the wiring diagram, we really want to look at this really close. So I'm using a professional information system to study the wiring diagram. On the wiring diagram, I have the connector for the camshaft position sensor and the crankshaft position sensor for a 4.7. Notice that the 5-volt supply, the yellow with pink tracer wire for 5-volt supply, is utilized for both the camshaft sensor and the crankshaft sensor. They also share a common ground. So the crankshaft sensor and the camshaft sensor have a common 5-volt supply and a common ground. Professional information also said that this vehicle has been fixed by replacing the crankshaft sensor and the camshaft sensor. But wait a minute, the customer says that's already been done. Here's the key point. They have to be replaced at the same time. They rob voltage drop from each other. If you don't replace them at the same time, the camshaft sensor will rob some of the 5-volt voltage from the crank sensor, and it will look terrible intermittently. And if you don't replace the crankshaft sensor, it will rob voltage drop from the cam sensor. They need to be replaced as a match set like a ring and pinion. Once we replace both the crank and the camshaft sensor with quality replacements from Dodge, the vehicle was fixed. The internet would say just replace the crankshaft sensor. Research, studying the wiring diagrams, studying the crank and camshaft relationship pattern, we were able to fix the vehicle by replacing both the sensors at the same time was the key point. The next case study doesn't really say the internet said to do this and then we never got to a repair, but it does bring up something that I want to share that we all should always keep in the back of our mind. When we replace a component, is it the cause or is it the effect? In this case, the component is an engine. It started off with high oil consumption and the engine was replaced. Within 30 days, the engine had failed again. Now, the engine was replaced because it failed a wet compression test. When they added oil, the compression came up showing worn rings. When I got involved in the vehicle, the phone call to me was, can you take a look at this '04 Kia? We're trying to figure out what would wear out the rings on an engine in less than 30 days. So we replaced the engine for worn rings and they're worn again. So obviously the engine rebuilder got involved and wanted to take a look at the engine that lasted less than 30 days to see if they might have made a mistake in setting the ring end gaps or maybe not honed the block like it should be. If they made a mistake, they wanted to honor it, which is very reputable. They called back and said, do you have any enemies? It appears somebody put sand in the oil. Like, I don't know why anybody would put sand in the oil. No, we don't believe that, that's happened. He says, well, there's a lot of abrasives that looks like sand in the oil, and but we want your business and we're going to take care of it this time, but you need to really find out how this abrasive material that looks like sand is getting into the engine. So the replacement engine arrived, the second one, and when we're putting the exhaust back on, we heard a rattle in the exhaust system. Upon further inspection, you can see the worn cylinder, the worn piston, and there's the cause. The effect was the worn engine, the rings from the abrasive material. The cause was the catalytic converter coming apart. The platinum, the palladium, the rhodium, the ceramic structure of the catalytic converter comes apart. Now you're saying, how does that get drawn into the engine? Through reversion. There are times in where it may be only a small amount on an OE production engine that the intake and the exhaust valve are open at the same time. This creates reversion and draws the exhaust pulses into the engine. Those exhaust pulses contain the abrasive material from the catalytic converter and wore the engine out in less than 30 days. So the point is, whatever it is you're replacing, you always have to ask yourself that all-important question. Am I replacing the cause or the effect? If you're replacing the effect, you're going to see that vehicle again because the cause is going to come back and bite you. Here's a case study where the internet became a pitfall. Customer complaint was a ticking noise coming from the engine on a 07 Dodge Charger 3.5 engine. He thought he'd done his homework. He had searched the internet for ticking noise for a Dodge Charger and came up that there was a service bulletin from Chrysler to replace all of the rocker arms. So he had all the rocker arms replaced and the ticking noise is still there. Again, the lifters are in the, as you can see here, the lifters are in the end of the rocker arm. So we had excessive clearance in the hydraulic lifters. Again, we noticed that there was quite a little bit of varnish and tarnish and sludge throughout the engine. So we used the same fix as we did on this Camaro. We drained the oil, put in 6 quarts of automatic transmission fluid, and on this one, the longer that it ran, we actually ran it for 2 hours. The first hour, it was sounding better, very faint ticking noise. By the second hour of idling, the noise was completely gone and the vehicle was fixed. You know how powerful the detergent is with automatic transmission fluid. If you're underneath a vehicle and there's a leak, and wherever the leak is, it was really, really clean, it's leaking automatic transmission fluid. Along with it could be red, but sometimes when an automatic transmission fluid is older, it'll have a brown color and could look like oil. If you're leaking transmission fluid, automatic transmission fluid, it'll leave a clean area wherever that automatic transmission fluid was flowing. That's why the automatic transmission fluid does such a good job at cleaning the engine. Key point here, do not drive the vehicle. It is a low viscosity fluid and you should only let it idle in your shop. Here we go with another case study. In this case, the customer seemed to be going on a pretty valid path of information from the internet. It's a 2008 Ford Explorer with a 4-liter V6 engine. Check engine light on, and he's pulling a code for a manifold absolute pressure / baro sensor. Now the internet, notice the information here provided, it's verbatim, as the customer printed it out and brought it to me. It says, the mass airflow sensor has the map readings built into it, as you already know. This means that the computer is reading the mass airflow incorrectly and either needs to be flashed or replaced. So this is a verbatim printed out from the internet that the customer brought to me. he's already pretty much diagnosing it, saying, I either need the computer reflashed or a mass airflow sensor, because the information that the computer utilizes is built into the mass airflow transfer function. He even provided me with a chart that he got off the internet for the mass airflow sensor function. Here's the problem. I would say that 75% of the Ford vehicles that are out there, his information is correct, except this 4-liter Explorer has what's known as an EGR system module. An EGR system module, as you see here, contains the differential pressure feedback EGR sensor. It is the EGR valve, and it is the EVR exhaust valve regulator, all built into one unit. And it is what provides barometric pressure and manifold absolute pressure information to the computer. The fix is to check the power and the ground, the 5-volt supply to this component. If it's all okay, replace the component. And summing it up, the information is correct for about 75% of the Ford vehicles out there on his information about the mass airflow sensor and map baro sensor relationship. However, professional level information and research would have revealed that the information was built into the EGR system module and not the mass airflow sensor. The EGR system module was replaced, the light went away, and all is well with the vehicle. In conclusion, I hope you realize that the internet, it is a wealth of information, but it's only a tool and should only be used as such. Think about it. You'll never go to a doctor that doesn't do blood pressure, temperature, and pulse. Why would you deviate on fixing a car? Get yourself into a set routine. Yes, you can use the internet, but utilize it with caution. I'm Ron Bilyeu. Thanks for watching.